In software engineering, we are taking a question and answer multiple choice questions on the software maintenance. The first question is software maintenance includes. So software maintenance is a phase in software development life cycle. It is the last phase in the software development life cycle. So in this, error correction is done, the capabilities enhancement is done, and if there are certain capabilities which are outdated or obsolete, they are also deleted. So the answer here is all of the above, all of the mentioned. D is the answer. Maintenance is classified into how many categories? So let me give you the answer first, then I'll tell you. Actually, the answer is 4, but in some of the book, for this software, for example, the RAJIB Mall's book, they have said the maintenance is of 3 types. They have not given this preventive. So adaptive, corrective, perfective and preventive. Now let me tell you that these all 4 we have to mention. So all these 4 types of maintenance are there. The preventive is that some failure cannot happen. So you have to routinely check for any kind of issues or failure that may happen in the future. So it's kind of doing all the things so that the fire cannot happen. Corrective is fire has happened, now you want to avoid it or you want to mitigate it. So correcting is all about bug fixing. Adaptive is when a new configuration, new operating system or new kind of say software you have to go through. You have to say translate or say you have to transit. Adaptive is done. Perfective is that user want perfection. That is, he wants some enhancement in the capability. The modification of the software to match changes in the ever-changing environment falls under which category of software maintenance? So all 4 I have shown you, but let me tell you again. So this is changing environment. As I said, when we transfer from Windows 10 to Windows 11 or any other operating system or hardware, then you need to do the adaptive kind of this change modification. So maintaining usable in a changing environment is the adaptive kind of software maintenance. Okay. Say this is basically, sometimes Windows 10 is there, now Windows 11, the Windows is by itself giving Windows 11. So when you jump to this Windows 11, some of the software may not work. For that you have to do this. What type of software testing is generally used in software maintenance? So in software maintenance is all about bug fixing, changes, modification, etc. So what we say here is that regression testing is what is done, because it is all about changing. So what we do, regression testing, there are different ways. In all the test cases are applied, that is retest all. Then we can check or just find out one set of this test, that is called regression test selection, or we can prioritize also. Regression testing is very expensive activity. Yes, this is absolutely true, because this regression testing is done always whenever there is certain change. So the changes will be done in the previous part also, and any kind of software development lifecycle part, there will be changes. There has to be some regression testing and it will be expensive. Selective retest technique may be more economical than the retest all technique. How many selective retest techniques are there? So see, first of all, selective retest technique means you are going to do the regression testing, and for that you have to select certain test cases from the existing test cases. So for that we have coverage techniques and save techniques. So here the retest techniques, there are 3 of them: coverage techniques, minimization techniques and save techniques. So this selective retest technique is an approach of performing regression testing over a software product using a minimal and specific set of test cases available in test suites. So what kind of coverage you want, you do the coverage techniques. Minimum you want, take the minimum which is corresponding to that minimization, and similarly the safe techniques. We have a question about that. So the number is 3 actually. Which selective retest technique selects every test case that causes a modified program to produce a different output than its original version? So as we just discussed just now, the answer here is C, safe. So this selective retest technique selects every test case that causes a modified program to produce a different output than its original version. So this is the safe technique. So safe technique does not focus or consider the coverage area criteria. Instead, they select every test case that cause a modified program to produce different output than its original version. So the answer here is safe techniques. Dash measures the ability of a regression test selection technique to handle the realistic applications. So this, as we say, that we know already that regression technique what it is. So the answer is generality. The answer is generality. So the categories on which the techniques, all these coverage, minimization and safe can be compared are inclusiveness, precision, efficiency and generality. So generality measures the ability of a technique to handle the realistic and diverse language constructs, arbitrarily complex modification and the realistic testing application. For this you will write generality. Okay. For example, you have different language constructs. We are talking here about the application which are very realistic and we need everyone is using it. So here we need to use the general for generic purpose. Which regression test selection technique exposes faults caused by modification? Some modification is done, then the regression test technique will show you that because of this modification, these are the faults which have come up. So for that, the categories on which the techniques can be compared, which one will be used here? The answer will be inclusiveness. So we just talked about generality, here inclusiveness. So inclusiveness measures the extent to which a technique chooses test cases that will cause the modified program to produce different output than the original program. That is, the original program is giving some value and the modified is giving some other value. So here you can say it is exposing the fault because of the change or because of the modification. The process of generating analysis and design document is known as. Now this question is coming from because you are generating an analysis and design document from this raw code, software code. So you have a code. Let me show you here. The answer here is C, which is the reverse engineering. Reverse engineering is a part of software re-engineering. So you have a code, you don't have any support, you don't have any supporting document, or even the in text is also not there. No support. So from code you try to find out the design. From design you try to find out the original software requirement specification. So first you have to clean the code. There may be code which is not clean, so you have to refine the code. Then you do the design extraction part, and then you try to find out the initial specification. Then you have to refine and simplify also this, and then you get the final specification. This reverse engineering, as I said, sometimes difficult, unknown, hidden information is there. So you need to take that out. That can be done only through reverse engineering. What is a software patch? Now, if you're say a small cut is cut in your hand, what will you do? You will put a band-aid. So this is a patch which you will put. Then you will go in the evening and you will try to go for the tetanus injection. But this software patch is an emergency fix which is worked upon the obsolete version whenever a vulnerability is encountered. Whenever there is a problem, whenever there is some situation, we just do, because some water is coming out, you just have to plug in some cloth. That is the thing. Which one of the following is not a maintenance model? Waterfall model is a software development life cycle model reuse oriented model, iterative enhancement model, quick fix model, they are all maintenance model. So which one is not? Answer is A. Waterfall model is actually a SDLC, software development lifecycle model. What does ACT stands for in BOEM model for software maintenance? So let me show you here. This is a part of this comes under software maintenance only. So BOEM used a quantity called annual change traffic, ACT. So ACT is computed by how many line of code added, how many line of code deleted divided by how many line of code in kilos, total one. Then we multiply this with some SDE. SDE is the software development effort, which is in percent month. Then we come with AME. So ACT is asking here, ACE is C. This is the annual change traffic, ACT. Choose the suitable options with respect to regression testing. So just read out here and I'll just give you an answer. Then I'll try to explain it. See, this is the regression part. Regression testing is happening. So the answer here is it helps in development and maintenance of software. So regression testing is all about changing. It means checking something bad has happened as a result of certain modification or change. So regression testing preserves the quality and reliability of the software, and it ensures that the software will work similar way as it was working previously. That is why we are using regression testing, because it doesn't compromise or it doesn't change the quality and reliability. What are legacy systems? Legacy systems are the old system. It may be as old as 1960s system. It may be as old as 2 or 3, 4 years back. Actually, the old systems are called legacy systems. So most of the time, these legacy systems are attributed by higher maintenance costs, data loss, lower performance, technical limitation, and now you can just migrate it, and that is why we do the software maintenance activity. So this legacy system require modification and maintenance. Which of the following manuals is not a user documentation? User documentation means you are going to give it to the user. User will use it. So SRS is software requirement specification. Beginner guide, installation guide, reference guide is all for the user. SRS is a document which is agreed upon by user, that is the stakeholder, and yourself, that is the software team, that this is the work we are going to do. These are the requirements, these are the use cases which we are going to implement. So the SRS provides information on exact requirements of system as agreed upon between the users and the developers. So it is not the user documentation. Which of the following manuals is a user documentation? The user documentation which you can give to the user, you have intentionally made for user. SRS, software requirement specification, software design document, no. So system overview, you have to give the overview of the system to the user. For that system overview can be used. System overview provides general description of the system function. The process of transforming a model into source code is known as. Now we are talking in terms of software maintenance. Let me give you an answer here. Forward engineering. We just talked about the reverse engineering. So you have an existing software that need maintenance, that the cost of maintenance is lower than the cost of changing the software. The software is not having any supporting cast and crew, that is documentation, etc. So what you will do is, from the code you will try to find out the design, and from the design you will try to find out the requirement specification. So now this reverse engineering gives you the requirement specification from the raw code. Now when the requirement specification is gained, you will add the new requirements or new changes, and then you will do exactly same kind of software development which you have been doing in SDLCs. So the model here, you have a model now. Now you can convert it into the source code. That is called the forward engineering. How many stages are there in iterative enhancement model used during software maintenance? See, if you talk about iterative model in your software engineering SDLC, it will be 4. Okay, 4 phases are there. But we are talking about the iterative enhancement model in software maintenance. So when it comes, the stages are 3. In iterative enhancement model, we analyze. First of all, let me show you. We need to analyze the existing system. First, analysis of the existing system will be done. Then we will characterize the proposed modifications. Then we will redesign and implement the current version. So these are the 3 major stages in iterative enhancement model under software maintenance. So the answer is 3. In SDLC, iterative model 4. Okay. Which of the following is true about the corrective maintenance? So there are 4 types of maintenance: corrective, adaptive, perfective and preventive. Okay. Now just see here, I'll just tell you the answer and then we'll discuss that. The answer here is, it is saying it is true for corrective. So corrective, it includes modification and updation done in order to correct or fix problem. So corrective maintenance is all about bug fixing. It identify and rectify an issue which are either discovered by user or concluded by the user error reports. The user has come up with some problem, you will correct it. That is called the corrective maintenance. This is the A is the answer. Others may not be true. A is the correct answer. You will take the A. Which of the following is not a type of maintenance? Adaptive, preventive, perfective, and one more is there. That is perfective, preventive, corrective is also there. So performative maintenance, there is nothing called in software maintenance. There is nothing called performative maintenance. So D is the answer. The cost of maintenance is as high as a dash of the cost of entire software process cycle. So you see here from the diagram itself, it is clear, it is 67%. Maintenance, the effort, the cost of maintenance is highest, 67%. So study on estimating software maintenance, it has found the cost of maintenance is as high as 67% of the cost of entire software development lifecycle. Which process is used to achieve system specification? By thoroughly analyzing, understanding the existing system. We just talked about that. Existing system is with you, you need to understand it, and then you would like to try to find out the design, then the requirement specification. So this is the reverse engineering. It is the process to achieve system specification by thoroughly analyzing, understanding the existing system. That is, you have to learn, clean, understand the code, then you go to the design part, that is you try to extract the design, and finally the specification part. This is called reverse engineering. In how many categories software maintenance is classified? So we already know this. Software maintenance, there are 4: adaptive, corrective, perfective, preventive. You may be asking why this question is coming again and again, because this question is asked again and again. What type of software testing is generally used in software maintenance? Now you may answer it. We have already discussed. It's a regression testing, because software maintenance is all about change, is all about maintenance. So regression testing is a software testing generally used in software maintenance, because there will be change, and change is always, because one more thing, reliability and quality doesn't change. That is why we use regression testing. Which regression test selection technique exposes faults caused by modification? So this also we have discussed. The answer is C. It is inclusiveness. This one measures the extent to which a technique chooses test cases. The process of obtaining desired software from the specifications in hand. This is called the forward engineering. So now specifications you have, you will design it and then design and then code. So this is only when we are discussing software maintenance. Otherwise there will be a different answer. So the answer is forward engineering. So you have first, this forward engineering is always followed by the reverse engineering, which is actually trying to find out the requirement specification from the code, and then we'll do the forward engineering. That is, now you have the new requirement specification, then you will design it and then we'll code it. So this the first thing is the reverse engineering, then the forward engineering. We combine them, that is called the software re-engineering. Okay, this is all about this question. Thank you so much. Take care of yourself.